In algebra, we sometimes use symbols in place of numbers or expressions. X equals 4 times 12, for example, defines a relationship between the symbol x and the expression 4 times 12. Remember that in math, a definition doesn't actually produce a value. If I want to see the value of a variable, I have to use it in an expression. Value definitions work the same way in our programming language. If I enter this code into the definitions window and click Run, I won't get any value back because a definition by itself has no value. I can use the variable, however, either by including it in an expression or just evaluating it down in the interactions window. In Unit 3 of Bootstrap, students learn how to define values of their own, as they define values for the title of their game and for each of their characters. By clicking Run and then evaluating danger, target, player, or background in the interactions window, students can see what their individual game images look like. Defining values buys us more than just readability. It also helps eliminate duplicated effort and prevent bugs. Suppose a program draws 1,000 green triangles on the screen, specifying each triangle by writing the same expression over and over and over and over. If the game designer suddenly wants to make those triangles red, she has to change the color in 1,000 different places. Not only is this a lot of work, but there's now 1,000 different places where she could make a mistake. Instead, a smart programmer defines a name for the triangle just once, and then uses that name in 1,000 places. To change the color, she only needs to change the color in the value definition, and that change will be reflected everywhere the value is used. In Unit 3, students select their game images and can spend time tweaking them so they look right for their games. If an image is the wrong size, they can use the scale function to grow or shrink it. They're free to use other functions as well, such as rotate, flip vertical, or flip horizontal. By clicking Run and evaluating their images one at a time, they can see exactly how they will look before they're added to their video game. Values can be more sophisticated than a single number or image. In Unit 3, students learn about the putImage function, which puts one picture on top of another, offset by the given x and y coordinates. With this function, students can stack together each of their game images to create a screenshot of their video game, with each of their characters displayed at a location they choose. The game template students start with already has an example of this function being used, to define a value called screenshot. When all of the inputs to each function are lined up, you're going to notice a sort of stair-step pattern emerging. And this is a good way to remember which expressions are inputs to which functions. The screenshot is a great way to give younger students more practice with coordinate planes. Keep in mind that screenshot is not connected to the actual game engine, so changing these coordinates aren't going to affect where characters appear during the actual game. Instead, it's just an expression you can use to test out where things are located given the coordinates they choose.